All right. Hello, folks. We're back at it again with another episode from Come Cloud with Us. And tonight we're going to cover some best practices, some .NET things, and some Docker. But first, I'd like to introduce our host, our co-host, Abdul. How's it going, Abdul?
Good, Chris. How's it going?
Good, good.
Good, good.
Um, feel like everybody's a little rushed today, but that's okay. We'll kind of get through this all. We have our guest speaker with us, so if you don't mind, go ahead and introduce yourself, please.
Okay, thank you. Thank you for inviting me today. So I am Hamida Rebai. I am Cloud Solution Architect. I am Microsoft MVP in Developer Technologies, Docker Captain. So I will present today some best practices for .NET 8, the latest version, for to create our optimized specifically Docker images. So we talk about containers, Docker. Yeah.
That's fantastic. Glad you could join
Okay.
us. Oh,
And then from a Docker standpoint, right? You said so you have MVP and you have other designations. So talk about that, like because
Yeah,
people are
Docker
probably
Captain. Yeah.
yeah,
Docker Captain. So it's I'm a part of Docker communities. So as Docker captains, we contribute we contributed with articles, with videos. So we try to contribute in conferences as we do as IVP also. So it's the same concept. Yes, it's another community that I really happy to join from last year. Yeah.
nice, nice. That's
fantastic.
impressive actually, because just keeping up with MVP, it's work by itself. So yeah, getting
Yeah.
MVP and all the others. I see people they have quite a bit now, like MVP. Some people are HashiCorp and
Yeah.
Mhm.
Dockers and yeah, it's just keeping up and even the technology itself that you are covering moves so fast to keeping up with that. It's like it seems like it's there's no depth now. It's so much breadth, like so many things are coming out and moving so fast.
Yeah, exactly. Yes, and as MVP or Docker captain, so we keep always updated about what's new. We know that containers now it's new, let's say new from last year. Now we talk about Docker containers, Kubernetes also, so large another communities. So we orchestrator, I would like to say, with cloud services because I'm cloud solution architect. So I'm working in government, in Quebec government. So we try to select the suitable architecture and solution to move to the cloud also. So container is coming here also with serverless, let's say, with other concepts. Yeah.
Nice.
Okay. And kind of talk about your journey to the cloud. Like how did you get into cloud?
So my journey in the cloud, let's say, so we started with ecosystem evaluation. Let's say we try to. It's what it was for us as a government. We know government's specific, not like private sector. We it was opportunity to discover our ecosystem, internal ecosystem. So we try to see the legacy solution. We are all legacy, and which opportunities that we can get if you'd like to move to the cloud, like being cloud ready, which means that we try to decouple our systems, use maybe portable solution like containers, maybe so let's say event-driven architecture. So we try to move not faster, but try to start with cloud ready before going to the cloud native solution like microservices, for example. So here we are in step that we try to check which solution can be. We moved already one or two solution to we are multi cloud, so to two providers Azure and AWS, let's say, and it's complex also in this case. So I know to start with the more than one provider, cloud provider, but we try to work more about a new solution to select which provider, how we can move the solution using the best practices, and its opportunity at least to modernize our legacies applications.
Yeah, that makes sense. And especially now, a lot of enterprises and even public sector,
Yeah,
they are going to
correct.
multi-cloud now. So
Yeah,
yeah. Um, okay.
yeah.
With that being said, we'll give you the floor and then let you run with your presentation.
Okay, thank you. So
Thank you.
Thank you.
Thank you.
So I leave here in this, let's say this slide, my, if you have any question after the session, maybe we leave time for questions after in the end. But if you have any question, you can reach me by my Twitter, LinkedIn, my email, for example, or blog. So I'm sharing always some blogs that's related about to Azure cloud and maybe for a Docker also. So we can find multiple art blogs in my blog. So I will start by talking about containers, Docker, for example. So what's the containers? Why we use Docker? Difference between container, because yes, we talk about Docker container, but here we'll try to prefer an optimized Docker image. So what's the difference between container and image? What is Docker file? And we have some demos. So we see how we can optimize our images. We'll see which tools we are able to use. So what is container? Container, it's like a transportation container. It's the same. It's a unit of software that packages code with its required dependencies in order to run it in an isolated, controlled environment. And this allows you to run an application in a way that is predictable, repeatable, and without and certainly of and consistent code execution across diverse development and production environments. A container will always start up and run code the same way, regardless of what machine it exists on. So it comes to resolve a problem. I have a background developer. I was a developer before, .NET developer specifically, and I know when we work in our internal machine, it works fine. But when we try to deploy it in production or any other environment, we need sometimes to fix to code. Maybe we change some configuration. Maybe we need to update our internal environment in the same way as the production environment and try to fix these issues. But container is here really give a hand to developers to resolve this problem. So what it works in your machine is the same. It's like cloning your application. And containers provide benefits on multiple levels in terms of physical allocation of resources. And containers provide efficient distribution of compute power and memory. However, containers also enable new design paradigms by the separation of your application code and infrastructure code. The design separation also enables specialization within teams of developers and allowing developer to focus on only on development of your application. So we don't care about any infrastructure because you are able to set up specific tools internally. Now we talk about development environment. You set up a development environment. It can be in your machine, it can be in the cloud using a multiple solution like Microsoft DevBox, for I give an example, or GitHub Code Spaces, for example. So that includes a specific environment, a ready environment for you. So you don't need to set up only in your machine, but allows you to create, to build and run container as a developer. And it's the same when you deploy. It's the same environment as similar to production. We'll see how. So and after. And here can we talk about Docker, that is container management service. This is why we talk about container and Docker. It's most used as a container management service. And the keywords of Docker are, if we open the website of Docker, we have some, let's say, some keywords. It's develop, ship, and run anywhere. The whole idea of Docker is for developers to easily develop applications, ship them into containers, which can then be deployed anywhere. And Docker offer different features. For example, so Docker has the ability to reduce the size of development by providing a smaller footprint of the operating system via containers. So we focus only on what our application needs. It's why we talk about memory, optimizing the memory, your operating system, your runtime. So the application, we get only what the application needs. We don't. It's not the same as preparing a virtual machine. So our application will consume the all of of the resources, memory, and processor. In this case, we already only create an environment. That's why we call it a container, and our application will use only what it needs. So as runtime operating system. So with containers, it becomes easier for teams across different units, such as development, Q&A, and operations, to work seamlessly across application. You can deploy Docker containers anywhere on any physical and virtual machines, and even on the cloud. And now we can see some specific features that can offer that Docker offer for us. If you would like to just set up your environment, your developer environment from a machine, you can use a cloud solution, a cloud environment in Docker also. Or Docker is offering now a solution for in the cloud also. So since Docker containers are pretty lightweight, they are very easy scalable in this case. Let's take a look about Docker components. Just we see what can Docker includes. Let's start by the first one, that is Docker app. So from here, we see Ubuntu, in Linux, Windows, sorry, and Nginx, for example. So this is your registry, which is used to host various Docker images. So when we try to access Docker app, we need to create an account. After it offer you a registry, it's private registry, and this registry includes different images, and they are public images, and we maybe as a best practices to secure images, it's open source. Yes, it's open, we are able to use these images, but you need to select images that Docker can approve them, or that is coming from a specific provider, let's say, or a partner of Docker like Microsoft. So we'll use after a .NET image to build our images, but we need to have the runtime image for SDK image, for example, of .NET. So a registry service is cloud based. So we use it. It's Docker Hub registry. It allows you to link to code repositories, and you can build images and test them. You are able also to store images that are manually pushed. So you can create your own image and you push it in Docker Hub. Docker Hub is a private registry because it's public registry. Sorry, it's not private. It's a public registry. You are able to create only one if you private registry for free. Else you can move it to paid plans for Docker to get more private registry. And we know that we have other solution. Our registry in Azure, for example, like Azure um, container registry, or any other tiers like a JFrog, Artifactory. So they are always some registry, but Docker Hub includes public images. So it links to Docker Cloud to help deploy images to hosts. So to summarize all of this, so we can understand that Docker Hub registry as a tool that offers centralized resources for discovering a container image, managing distribution and change, facilitating collaboration between the user and team, and automating workflow throughout the development pipelines. Because here, so yes, okay, it offer you, maybe we can use the private registry with paid, but we need to create a pipeline that allow us to push automatically our images uh, according to our needs. So we push, so we make some updates. So we need to automate the pipeline and this one. And we have another process. Maybe we don't talk about it. That is the process of hardening the images. This process allows as company, I recommend that all. It's not related to public companies or government, for example, or private. We recommend it for all that you automate your process of hardening images. So yes, we can get some images from Windows, but we need to scan these images using specific tools. And if image is ready. With without vulnerabilities. In this case, we can add it in registry, and we can use it in to create other images. So we can share the images, and this process we call it hardening of the images. We After we use these images, we share these images with different developer, so we don't need to get these images from Docker publicly, for example, if you need to secure really your images. Now we talk about what is Docker. Docker is the architecture of Docker. It uses a client server architecture, and the Docker client talks to the Docker daemons, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and daemon can run on the same system, or you can connect the Docker client to remote Docker daemon. The Docker client and daemon communicate using a REST API over Unix sockets and the network interface. And another Docker client is Docker Compose that lets you work with application consisting of a set of container. So we have a different layers as we see here. So we start by the server that is a physical server that is used to host multiple virtual machines. So this layer remains the same as any virtual, let's say virtual machines. Next, the host operating system is the base machines, for example, Linux, Windows. So this layer remain also the same as virtual machines also. But let's take a look about the difference between virtual machines here and Docker. And in our Docker architected, it's it's here the new generation that is Docker Engine. This is used to run the operating system, which area used to be virtual machines as Docker containers. And all of the application now will run as Docker containers. And here we can see different applications. So the engine is the difference between the new, let's say, the new generation that comes with containers. That is Docker engine. So this is about Docker architected, and we know that we said that we have Linux container. We can create Linux container or Windows container, which means that uh, I am using Windows 11 actually, and I'm able to build and run a Linux container. Why? Because Linux container run Linux apps on Linux hosts, okay. But if you are using but for Windows container, we know that Windows container run a Windows application on Windows hosts, okay. So it's normal here. But the exception to this rule is Windows host with WSL2 installed. So we set up WSL2. It's related to your operating system, Windows subsystem for Linux, and provide Linux kernel on Windows hosts. This host can run Windows and Linux container, and despite this, the vast majority of container are Linux, and you it's really rarely see Windows containers. And we see that a lot of changes, it comes always with Linux images, Linux operating system. But I'm here using a Windows operating system, and I will build and run images on a Linux operating system because we use WSL2 that is already installed. Now let's see the difference between Docker container and image. We talk about container, we talk about image, but what is the difference between them? So let's start by the first one, that is Docker container. It's virtualized runtime environment that is used in application development. So this is the definition of Docker. What is Docker? And it enables us to create, run, deploy applications that are isolated from the underlying hardware. A Docker container can use just one machine, share its kernel and virtualized operating system to run more isolated processes. So Docker containers are lightweight. We get small, really. We see that we today we talk about how we can optimize, prepare an image, Docker image. We see how it's really small, and we try to make it more small, and specifically for more it's to for security purpose, it's small, so we are able to secure it better. Docker image, it's like a snapshot in another types of virtual machines environments, and it's like a record of a Docker container at specific point in time. So Docker image are also immutable. Why they can't be changed? They can be duplicated, shared, and deleted. This is why we said that we push images and we are able to reuse these images. And the feature is useful for Testing new software and configuration, because whatever happens, the image remains unchanged. And we use them specifically. We can use Docker images to for runtime. We will see that in our Docker file to get specific for example, for ASP, for example, ASP.NET, specific version of ASP.NET. So we will try to reuse these immutable images. And containers require the existing runnable images to exist. And we can't start without any image. So in our case, if I'm using .NET application, I need to use existing images to create our Docker file that we presented after and that we will try to optimize it after. If I'm using Python, for example, I need to an image related to the runtime of Python at least. And so they are dependent on images because they are used to construct runtime environments and are needed to run application. How I can run my application? So we said that's a really container that include all what my application need. My application need operating system, specific resources, and needs. Really, we need a runtime related to the the language that we will use. So the main steps in taking an application from source code to running a container are really simple. We can see that. So you develop your application, you build application and dependency in an image. So we create our image. We see how you ship the image to a registry. Not necessarily. It's really optional in this case. So you can ship it, or you can already use it in internally after you ship your image in the end, or you create only you ship your container and you run it as a container. So we run container using an image. So the whole process, as you can see, it's really simple. So we package the application as an image and we run it as a container. So we have two main steps. And our image, as we can see, it's a collection of layers that comprise the application and all dependencies. The most common way to build an image is with Dockerfile and Docker build commands. So what is Dockerfile? So we talk about the Dockerfile. What is the role of Dockerfile? The Docker file is a list of different instructions that tell a Docker build how to build the image. It's specific scripts composed of various commands structure and arguments. We can get specific arguments listed successively to automatically perform action on a base image in order to create or form a new one. They are used for organizing things and greatly help with deployments by specifying the process start to finish. And Docker files begins with defining an image using from which the build process starts, following by various other methods, commands, and arguments or condition. In return, provide a new image which is to be used for creating Docker containers. And images are used to start one or more containers. So if you are a developer, think of images and container as classes and objects. So it's the same concepts. We have classes, we create our objects by using, so by instantiating these classes. So we create containers from images in the similar way to creating objects from classes. So if you are more of, let's say, of a sysadmin or DevOps, it might be helpful to think of them as if you are a developer. Think of images and container as similar, as I said. So in this case, we have classes and objects, and in this case, we will create our image using our Docker file. Every application needs a Docker file to add. So let's suppose that you like to optimize my internal application using .NET, I don't know, the old .NET. So in this case, I need the Windows operating system because only .NET Core is able to deploy on Linux operating system. So you just add Docker file. You can generate it using Visual Studio. You can generate it using some command lines that Docker can offer you, like Docker init, for example. It allows you to generate automatically your Docker file that includes what you need. It's optimized really Docker file in this case, and it's what we need, what you need here to use and to run, to build your image and run your container. So because we Docker build, we use it Docker build as command line to create our image, and Docker run, we specify the image in this case to create our container. So it's this is the difference, let's say, between image container in a practical life, let's say. Now let's move to our Docker file. This is an example of Docker file for a .NET application, .NET 8 application. So as you can see here, in the beginning, we specify the image. Always we start with from this one, and we have work there. So for content, the first thing what we need is to define an image we want to base it on. We also need to set a working directory where we want the files to end up on the container. We do that with this command line from. As you can see here, we need to use the SDK. Here we have as build its multi-stage, so which means that we create different stages. So, but it's the sum of optimization that we cover today uh, by creating our image to optimize an image. But we have from your SDK, and in this case, you need what you need is you have work there, so you need to grab an image with a small operating system image for this version .NET 8. Next, so we need to copy the project file ending with csproj. Additionally, we also need to call .NET Restore because to ensure to install all specified dependency. So as you can see, we use .NET command line, CLI command line that we already use it internally, that always use it when we build any .NET application. So we restore what we need as dependency for our application. Next, okay, we try to restore. Let's do copy your app files and build your application. So we'll copy. So we need to use copy. We define where I would like to copy from to. And next we define your workspace where you'd like to copy your application. And we use another command line and here to copy your application, and we will build. We use run.net build. So I would like to use like command line.net build to build our application. We need to build it in release mode in this case, and all these files will be copied here in this case in the build. I'm not copied, but it will be using what we already restored here. So this is the release mode, and here the name of the repository that I will use it, that will includes all dependencies and our csproj, our DLL of our application. Next, we will specify our image and our working directory in this case, and we need another images to be able to execute our application in the end to publish it. This is why we call again from. We use always from uh, with images that we will use it, that we need to use it in our big image, because here we are creating a new image basing on existing images. So, and in this case here we start with from, and we will copy all the content of, again we copy here, we get our another image and we copy it in the workspace. Next we will copy all the content from build to the publish repository. So this is a difference through, this is the time we want to copy our build files, in this case to publish files. So now we move to starting our application, because we add a command. In this case, as you can see, we have endpoint. We can find other command lines. In this context, we will use only endpoints. It takes an array, as you can see, that transform into a command line invocation with arguments. This is why we have .NET in this case, and we have the our your DLL. And this is the content of our Docker file. To build your solution, we use Docker build. We use Docker build -t because we need to specify the name of my image. Else, Docker will give you a default name. We recommend to use a specific name. So this is why -t to give a name. This is the name, for example, of your image in this case. And here we have, as you can see, the tag. A tag is like version. If we are coming a Git world, let's say, as DevOps to pipeline. So this is like a version. So we are able to create multiple images with different tags. Here, for example, 1.0, we can use dev, you can use prod, you can use anything. So just specify the name of your image, and here we give the tag, and here we set in our current application here. So we have an image, now we have an image, it contains our application code, and we have everything: operating system, we have the runtime. If you remember SDK or ASP.NET, we have two images. We get some two images to be able to deploy our .NET application. Here we will use build. We already created our image. Next, we create our container, which means that we will run this image to create our container. That's why we said create container or run and run it. So this is why we use docker run -t, which means that we will run in background. It's optional. -p here, it means that we will match an external port. Here, this is the external port with internal container port. It can be different. It's not necessarily the same. And for some Dockerfile specification, you need to specify expose and internal port. This is not, sometimes it's not needed, but here we just use port 80. So you see here the syntax, it's external, internal port. Next, minus t and I in this case. Here we give a name. So we give a name minus name. This is the name of your container. If you don't give a name, you will have a generated name. It can be the name also your application that you already created. Here, a flag, a RAM flag that allows you just to remove any anonymous volumes associated with the container when the container is removed. And don't forget to specify which image you'd like to create for which image you'd like to create your container in this case. In our case, we can create it from dev image. For example, if we have dev here, 1, 2, specific, and we use the tag, the entire name. Don't forget the entire name. Sometimes if you forget about using, if you compile it automatically using Visual Studio 2022 or using some command lines related to Docker Compose, for example, in this case, you get latest as one latest, which means that's latest one. But we are able to personalize this one, so it's better to give some specific tags to your application. If you want to install Docker, as I said before, for personal use, you can you can install for free always Docker Desktop, like this one here. This is what we use today. This is Docker Desktop that we will use it today here. As you can see, we have some images. Here we get the images. We see here status in use. And here in use, which means that we have container that's already running. Here the status is not running, but our image is already used by specific container. And here you can see tag latest. Here we have another tag v1. This is, for example, have the tag dev. This is the name of image. This is the tag. And container, we can see the specified images that's already used, for example, in this case here. So always, so you can have other plans. You pay for the plans to get, for example, more for you can see the specification here, but if you'd like to have more, you have unlimited private repository. Here you have only You have a limited public, but you have only one. It allows you to create only one. If you have more needs, specific needs, if you are a big company, if you'd like to have more secure, let's say, and another environment. Here we talk about build cloud. This is the environment that allows you to build and to create, to use Docker Desktop. It's like using Docker Desktop to deploy your images in the cloud instead of using them here. You can configure that in your Visual Studio or Visual Studio Code, for example. So here, this version, specifically business, includes a hardened Docker desktop. It's more secured version that allows you to that at least it's really more secure. It's what we are using actually in government. We have a lot of flexibility to secure the daemon, so it allows you to secure all the environment. It allows you. It's really secured one, so secured version of Docker desktop. Else you can see a different plan. Here we go to the up Docker. You need to create an account and you need to install Docker desktop. I already displayed for you. And here it's really simple. You can have multiple solution like Docker Scout that allows you to scan your images. Another solution that comes with Docker and helps you in your hardening process to scan your images deeply. You can use other tools and other less tools for example, from HashiCorp. They have specific tools that we already use it here in where I'm working there, and we use also Docker Scout. So we improve the scan. So if you have some vulnerabilities, Docker Scout can help you to fix them also. In this case, sometimes vulnerability relate to operating system where your image is already running. Maybe sometimes comes with Ubuntu, some packages to need to add specifically. And here another file, Docker file. Uh, we can see here it's similar to what already presented before. You set up your base image with ASP runtime. You use the SDK is another way to classify, to reorder our Docker file. Here we restore package. So in this case, I'm using ASP.NET in the beginning. So we say I'm using what I need from ASP. I'm using the SDK. After I need to .NET restore. After we build, we publish, and in the end, I will using publishing. So we copy published files, and our image is ready to be built. Now for optimized Docker file for .NET application, we said that the .NET official .NET Docker images are publicly available in the Microsoft repository on Docker App. So you check Microsoft and you can find all the different repository that Microsoft is already publishing their images. The process of identifying and picking up the right container-based image while building application can be confusing. To simplify the selection process, most images repository provide extension tagging to help you select both a specific framework version. They also let you choose the right operating system, like specific Linux distribution or Windows version. So if you try to search for your specific image, as we see here, for example, let's go back here. So you have the version, you have the operating system. Here, for example, we see that we use specific distribution of Linux that's Alpine, that's optimized one. I recommend to use it. It's one of the best practices we recommended after. So it's really simple. And to find this one, you need to go to Docker app to search for the the specified this link according to what you need. Operating system, SDK runtime. So it depends. It depends from what you need as image. This is a basic Docker file. We already presented one. And we have, this is why we said the image, it's really stack of layers. So we have a different layer. And each one represent an abstraction in your Docker file. This is a layer. This is a second layer, the copy. So copy second layer, work there is another layer. And each layer contains changes to its underlying layer. Here an example, I give you a specific example here. You can see the size of image. Imagine that it is your size of your environment that includes your application, for example. So we know that in virtual machines, we use all the entire, let's say, capacity of a specific server or what we already defined in virtual machine to use as memory, as processes. So this is the size. And here to optimize our images, this is why I call that tag one. We need to work more to optimize about that. Let's start by how we can optimize the Docker file in the .NET Restore. When we build .NET Core application with Docker, we need to consider how Docker caches layer while building your application. So a common way to leverage the build cache is to copy only the csproj and SLN, the solution .sln, and NuGet config file for your application before performing a .NET Restore instead of copying the full source code. So the NuGet package restore can be the one of the slowest parts of the build, and it only depends of these files. By copying them first, Docker can cache the restore results. For example, if you won't need to run again, if you only change just only a CS file, for example. In this update here, we can see here an example how we can add these arguments. So let's start with the first one. Here we can use this argument publish ready true in .NET Restore. And we can also add this one single file here in your restore. Let's check how we can do that. Okay, so here the first one, this one, the first. Here we can see that we let's start by the different stage. The first stage here. This is why we call that multi-stage. Ah, okay, multi-stage. I think I missed it here. Missed my file. Sorry. So here, let's go here. Run .NET restore. This is if you remember our previous Docker file. Does it include minus Alpine? Alpine is a distribution of Linux. It's really better than using Ubuntu for this context. I'm not saying that's always use Alpine, but for .NET application, Alpine it's really we don't have vulnerabilities related to Alpine. We don't need to add specific packages to Alpines in this case. So we have Alpines, we added here, and we added Alpines here in ASP in our right side. You can find the link here by operating system. So by default, it's Ubuntu, for example, and you need to add other distribution in this way for in this case for Alpine. Let's move to .NET Restore. Here we add publish ready to run is true. This allows you to optimize the restore. So this is an argument that we are able we use all the entire arguments. Another argument we can see it in the build, for example, we already mentioned before. This is this one publish ready to run. Also we added, but to be able to build this one, you need to add Linux, this package, let's say this package before. So this is why we need to use the internal properties here, arguments. Okay, we say the arguments with .NET build. So we need to use this one with Linux here. For the publish, we can see the same. We have other arguments. These arguments allows you to optimize really your Docker file. We can see the difference here. We started with this one, and now as you can see, the first tag one, tag two here. So we started by the first one. After we optimized them, we see that already it's really optimized the minimal size. So we can't reduce more, but it's more optimized than before. As you can see, the difference between the sizes here. Now we talk about multi-stage. I said before we have as base, as build. We call that multi-stage builds. Docker can use one base image for compilation, packaging, and unit tests. Another image then holds the application runtime, and this makes the final image more secure and smaller in size, as it does not contain any development or debugging tools. Multi-stage Docker builds are a great way to ensure your build that's really predictable and as lean as possible. So you can create multiple stage as you can see here within Dockerfile and control how you build the image. The .NET SDK includes .NET runtimes and tooling to develop, build, and package .NET applications. This is why we use specific order in our Dockerfile. Sometimes we find ASP before SDK. Don't forget that .NET runtime is, as I said, and tooling, develop, build. It includes different requirements needed, different packages needed to build and to create your .NET application. And the best practice here is while creating Docker images is keeping the image compact. You can containerize your .NET application using multi-layer approach. So each layer may contain different parts of the application, like dependencies, source code, resources, and even snapshot dependency. Alternatively, you can build any application as a separate image from the final image that contains the runnable application. And this is an example here. We have the first stage, we call that build stage. We try to build our, let's say, runtime. We have SDK here, runtime, our runtime. So we started by the SDK Alpine. We have all what we need as built. Now we go to runtime stage. This is what we call base. You can call it any name. Okay, this is free for you. It ups to you. And here we get to build and we copy it in the publisher and it's simple. Here we expose 80 to force using the 80 port for here. If you'd like to, here we can say other keywords like expose to force the use of specific port when you run your application. CMD is similar like endpoint here, but it takes only one argument. So you can see all these elements in Dockerfile. Now, run as a non-root user for security purpose. This is important to do it when you work as a team, work together. Why? Because we are running an application within Docker containers. It has default access to the root for Linux or administrator privileges for Windows. This can undetermine application security. So you can solve this problem by adding user, its keyword here, its user instruction with your Docker file. And this user keyword, let's set the preferred username or UID, depends, and optionally the user group G. So these elements related to the architected and of Docker, UID, GID, while running the image, and for any subsequent run CMD or endpoint structure. Let's say how we see how we can do that. Here we added the command run add user disable password. Here the home app, Jucos, no root in this case, and you can see some command lines, Linux command lines, to say that we don't need to get to be no root. And next we give a name here, you to our new user that is not administrator, and we said my user is no root. So with the name is no root with the disabled password, as you can see, disabled password, and set the ownership of app directory to this user. So user no root, switch the user to no root for subsequent commands in the Docker file, as you can see here how we can use it. So this is the run and this is the user. So run command line to create a no root user with the specified parameters and then set the ownership for the app directory to this user using chnown. Sorry. And next we need to use user here to switch to no root by using this command line to perform operation during both the build and runtime stages, ensuring that the application runs with a reduced privilege for improved security. And this approach provides enhanced security by reducing the attack surface and mitigating potential security vulnerabilities that could be used by running the application as a no-root user in this case. So if anyone a hack can attack your image, so is not able to attack all the entire environment because you are not already administrator, so you can't do specific command lines as an administrator because we already defined a no root user. Here can be another command line. It depends from how which this is the minimum privilege, let's say, to no root, but you can specify more. You can give more privilege. You can specify specific privilege for this no root. You give a name, another root. So this is you can specify another name in this case. And when we create your application, if you would like to generate automatically your application, you will see that you have another file that's added. This is we call that Docker ignore. So to increase the build performance and as a general best practice in this case, we recommend creating, if it's not already created, .NET .docker ignore file in the same directory as your Docker file. It should be in the same level. So with this file, we can determine which components are vital, and they will ultimately belong to the new image that we are building. For example, in this case, if you don't want to include the bin and configuration, for example, conf directory in your image build, we just need to indicate to say, okay, in your Docker file, the Docker ignore, sorry, these elements. So it's really simple. I will just display a specific one. This is an example of Docker ignore. As you can see here, we define what I don't need really. I don't need class path. I don't need this environment. I don't need already also this file to be used when we try to create our image in this case. I don't need Docker compose in this case. So this is an example of Docker ignore. I will share with you an example of an application that's already with the specific tags that here it shows you. So this is a text file. This is my final Docker file that it comes in the end. And here I will share with you how we can start with the first one. For example, we call that tag the first image. The second one here, as you can see, I started. It's the first one, the basic one. This is the second one. I'm starting using Alpine, and here I'm start to using, for example, here adding this dependency here, this parameter, as you can see here. So this one and this one, I've tried to add my create my no root user. And the third one we will talk about that the next one, this next one. So I will share with you in the end this solution. And we need to add also the health check as structure that tells Docker how to test a container and confirm that it's still working. This can detect, for example, when a web server is stuck in an infinite loop and enable to handle a new connections even though the server process is still running. So when an application is deployed in production, an orchestrator like Kubernetes or a service fabric will most likely manage it by providing the health check. We use this keyword health check. This one, it's by providing this one, the keyword, you are sharing the status of your containers with the orchestrator to permit management tasks based on your configuration. So when health check is present, we can find in a Docker file, you will see the container's health in the status column while running Docker PS. So you use the command line Docker PS and you get all the information needed about the healthcare of your container or image. A container that passes these checks displays as healthy. An unhealthy container display as unhealthy. So you have some keywords. So you use Docker PS in this case. This is a really detailed example here if you are using this is for container, Linux container, and you have another example for Windows. For me, I'm compiling internally Linux container, but if you already use Windows, we have another example. So here, health check, we have interval, so we have some arguments, the timeout, the start period, number of trying to get your container, for example, and we have different elements here. And here, uh, if it doesn't work, what I need to do in this case for my application, it's like it's not displaying any status like the HTTP status. Here, it just will display only one another page. Here we see exit one. So this is the generic command line with some. I try to use the multiple arguments here, but it's not required to use all of them. But some example here, for example, for Windows, we use PowerShell in this case. So we need to say that we need to use PowerShell, and we write here PowerShell. You can see here we in Windows we use status code. It's like 200 yes 200. So we turn one 0, else I turn 1, which means that I have a problem in this. It's not healthy. Our container is not healthy. Is not answering. I get some issue, but it's not related to container, but the application is running inside the container, even container. This is another optimization to consider. Another one is you can optimize .NET application startup times and reduce latency by compiling your assemblies with ready-to-run compilation. However, this will increase your build time as a compromise. So it takes more time when you'd like to build your image. So you can do this by setting the publish ready to run. We already configured property with which takes effect when you publish an application. So we already use it here. This one published already in the running step and in the build step. If you remember in the previous the previous let's check the previous one, the build, the previous one here. So in the build, so we use this one and use this one already for publish and for build. But you can your application will take times to build when you use Docker build, so it takes more time than you need here. Now, let's talk more about some optimization in Windows container. Even it's not really used a lot in the market, but we need to optimize. So we have some .NET application, for example, that are deployed in Windows. So we need at least to optimize also Windows containers. So there are two distinct modes for runtime isolation for Windows containers. We have process isolation and hardware. In this case, we have, let's start with the process isolation. That in this mode, we have multiple container instances that can run concurrently in the same host with isolation on the file system, registry, network ports, process, thread ID space, and the manager namespace. It's almost identical to how Linux containers run. Another mode that is Hyper-V isolation. So we have process isolation and we have another mode that is Hyper-V isolation. In this mode, containers run inside a highly optimized virtual machine, which provides hardware level isolation between container and hosts, and hardware level isolation between container and hosts in this case. So most developers prefer process isolation when developing locally. It typically consumes fewer hardware resources than Hyper-V isolation. Hence, developer must account for the additional hardware needed when we'd like to run the container in Hyper-V mode. So, your primary consideration when you decline the choose, for example, Hyper-V, let's say isolation, is in this case security, since it provides added hardware level isolation. While Windows Server supports both options, so by default it's process isolation. We have Windows 8 Plus, let's say, only supports Hyper-V isolation. In this case here, we can see how we can specify the isolation. It's really simple. We need to add a new arguments. It's a flag. We call that flag isolation flag. So IT isolation process or the other one, library, for example. So here we have process. By default, it's process isolation. Now, let's take a look about other languages. So, for other languages, for example, here we don't talk about only .NET. It's we have other languages. It's the same as .NET, yes, because in other languages, here an example of Python. We have multi-stage. We need to optimize an image using the maybe this here, for example, Slim. That is a small version, for example. We need to apply the same parameters. Yes, so we have some the same, let's say, consideration as well as developing in using a .NET application. And here the latest, this is an example of Python optimized one. And this is another for Control M, for example. So we have other examples that it's the same. Here to resume what we already covered to optimize our image. So start choosing the right .NET Docker image, which means choosing the right operating system. In our case, it was Alpine. We need to optimize our .NET restore using some arguments to optimize this the Docker file. Always use multi-stage builds. In this case, we have not only one stage too, so we can get more. Yes, it's a simple. Our application is really simple. We created, for example, ASP.NET, but your solution can be more complex. Use specific base image tags for instead of latest, as I said before here. So when you build your images, you need to specify your tags. Else you get like me here. As we can see here, let's go back now. This is as you can see here, our image. You will get latest. It's okay. It will always change your image with the tag. Else you can just specify. It's better to specify your specific tags. Personalize your tag in this case. Run as a no-root user for security purpose. It's really important to do that. If really to like to secure your environment, you can have more security best practices to consider also for to secure your image. Use Docker ignore also, so you specify what your application don't need after compiling, executing your application. You can use caches, for example, for some NuGet caches instead of just restore or what you need. You can get them from the specific caches. You need to add health check to your container. This is a really good optimization for your container to get to see if it's working or not. And to maintain your image, your containers, optimize for startup performance, and for Windows container, specify your isolation mode that it suit your solution. I don't know if you have any questions here. I'm also author. I'm writing also books. I have two books already. The first one, this one, so I start from here, includes the different elements related to Docker. And here we can find how we can set up internally an internal environment, how you can use Docker, and it includes or how we can optimize your images, and it's focused more about also .NET application. And this one is more about APIs management, APIs, and here it's about also Azure. Thank you for joining me. I don't know if you have any question here.
That's awesome, awesome, awesome. We do have one question that's come in.
Okay.
And it's a little bit of a compound question, but the question to us was, I have a question regarding Docker security. The
Yeah.
attacker uses a Docker misconfiguration to escape out of Docker and pivot to the host machine. During the Docker initialization, is there any way that we can set up configuration or any checklist that we can refer to prevent this issue? What are your thoughts?
It's related to security, so
Hmm.
mhm. Uh, um, I don't know. I don't know how we can. given how we can resolve this issue about that. But maybe here for us, what we need to do is we try to secure the daemon. We try to minimize specific privilege to developer. We try to get images from a private registry. We don't use what is already we already show. For example, for us, we use internal links to get the SDK and runtime,
Mm.
and we talk about your hardening, your process to hardener. So we have also okay, we have Docker Scout that you can that allows you to at least to check your images. I don't know how we can resolve the issue. So think about, could you leave that in the chat so maybe I can answer it publicly. It can be
Yeah,
something, yes, to think about it. Can
absolutely.
give the right answer. Yeah.
Awesome. Awesome. I haven't seen any other questions, Howard. Yeah, we can pause for a second, just encourage other folks, any of our viewers. Thank you for tuning in. If there's any questions, now's your opportunity to kind of try and get some answers while we have you here live. So,
Yeah.
um,
I guess for me, and no questions, but hopefully we can go through the Docker desktop, look at the options, and just see what's out there.
Okay. For Docker desktop, for example, here, if I said we can use some command lines to build, to run, exactly. So we have an example here, and we can just check here our vulnerabilities. We can just see here. We don't have vulnerability because we are using Alpine in this case, but you can see the different layers in your image. For example, here Alpines use this. Why I focus more about Alpines, but it can be also another distribution according to the framework, let's say. But here we can see the different layers inside your image, what your version Alpine can include here. You we also we have the different packages also use it to build your image. You see that our image it's really small. For example, here we have here you can see it's really small. It's not small, and you see how it includes really different layer. I will come back here to the image. So just click here. You can see how many image we talked about uh, let's say certified, let's say images that you can use. Here we can see this Docker official image. We know that in Docker Hub we have different images, and here we can get this one. You can use this one. It's, let's say, analyzed by Docker. It's like certified by Docker, but even you can use Docker Scout. You can use Docker Scout. So it's here allows you to scan more your the image again, and you can see here you can export different images in GitHub here. I will let you check here. Here you can find more images in their GitHub. You can check Docker file of this specific image. For example, here for Docker Alpine, this is the specific image. You can you can find a different configuration here to select this one. For example, this 64 configuration, and you can check the small Docker file that you already exist. This one, another option here related to vulnerability, different packages, use it. In containers, it's more simple. Here I use it Docker Compose, for example, for this image, because you can use a Docker Compose app that allows you to build and run your application. We said that we already created Docker file, but you are able to create another file that is called, we call that Docker Compose. I don't have here Docker Compose, but so when you use Docker init, it create by default Docker Compose. Docker Compose is used for more than one container. If you
mm,
want, if you'd like to have more container, and you will run it in one single command line. So you can, for example, here I have only one, but I can have another one. I don't know if I have another specific one that includes two operating system here. I will see now in use. Now I don't have another example, But here, Docker Compose allows you to get more than to run to build more than one containers. And here we can see this is an example of an application that already use it by use that includes Docker Compose. For example, this is the web. You can have the database, for example. Here, another container inside this one, this package. So it's one package. Like you can see different layers here. Another option maybe. Docker Scout. So for me here, that allows you to, you can scan more here. You can see how we can use it here. And we
Mhm.
have another beta, the dev environment and extensions. Okay, we have a different extension. So you can explore different extension. You can install and use them here internally. Also, you can use Kubernetes here inside Docker. It's creating only one node, one
Mhm.
cluster, let's say, internally, but you are able at least to set up a minimum of configuration for your environment to use the Kubernetes. But here we have a different extension that allows you. You can find a lot of extension to map for to manage. I don't have any one used already, but you can search for the suitable one. And we talked before about the cloud environment also. I didn't use it yet here, but you can see here the configuration after. You can, instead of using this one internal, you can use the cloud environment prepared by Docker also. Okay, another question here.
Cool. Cool, cool, cool. Yeah, so we did have, thank you for that. We did have one other question come in.
Okay.
Just a clarification between the difference between Docker and Kubernetes. Um,
So Docker is for one container. Kubernetes it comes here to orchestrate between different containers. So we need if we okay one containers okay for monolithic let's say application, but we will use Kubernetes to orchestrate between containers because we need to build let's say microservices solution. Sometimes we have multiple services, multiple containers. We communicate with each other with APIs with any other let's say communication. So we need Kubernetes. It comes to add more for another option that's orchestrating containers that are Docker based on Docker. So it's not the same solution. It comes to complete the solution there. Yeah.
awesome. Good answer.
Yeah.
Good answer. Um, I don't see any other questions. I will. I always ask a security related question. I feel, but just briefly, when we talk about like a lot of the work that I do is related to encryption and services and secret management. So, could you talk a little bit about how secrets are managed inside of Docker and Docker images?
How we can secure images, right? If it's like building a hardening process in this case, as we talked about before,
More of.
more
So if I
deeper.
have if I've created a service and I'm running in that Docker image, like how do I maybe retrieve or secure a secret that I would need to have that service or that microservice run?
Okay, so if you have multiple container to secure, so you need to set up some security. Let's say we need to secure the interaction between the different containers, secure how when they try to communicate each other. So we have a lot of security, let's say, tools. We can use some specific tools. So it depends from how is your application. So in this case, so it's security more here. And think about that. How we can give you a good answer in this case. So but so it depends. So as I said here in our case, we try just to secure the access of a specific user. We try to block
Mhm.
the administrator access. In our case, to it's when someone try to access to our image. So we don't allow to this let's say hacker to access to the other image because we know the host include different containers. This is one of the best practices. Next, so we need to set up maybe other tools inside the host of Docker, entire in the virtual machines for it. Let's include its containers. So I don't know. So how it's global, it's generic answer. Sorry for that. Yeah.
No, 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 that's fine. That's totally fine. Um, Shiva, I just want to say thank you. Call you out. So great questions, great answers. I see some stuff coming in here, but Abdul, are there any other questions, thoughts
No,
regarding
no,
session?
no questions for me, but this was amazing session.
Thank you.
Hamida, thank you so much for coming on. I'm sure this was fairly beneficial for our viewers, and I learned quite a bit too. And honestly, looking at this, this is easy. Like it looks easy, I know, like, but there's so much that needs to be done,
Yeah.
and because it's open source, there's so many technologies like
Yeah.
.NET and others that people need to know. But yeah, this was a great overview. Thank you so much for this.
Thank you.
Same,
Yes. Yeah.
same, same.
Happy
Well
to share
done.
that. Yeah.
So with that, I would say this ends another session of Come Cloud with us. Thank you so much, Mita. Thank you to our
Yeah.
viewers. Thank you,
Yeah.
fans, and we'll see you next time on
Yeah.
Come Cloud with us.
Hi.
Take
Thank you
care.
so much. Bye bye.
Yes. Bye.